Hi everyone, it's Charles from Letta. Today I'm going to be talking about Anthropic's brand new model release, Sonnet 4.5. And specifically, I'm going to be focusing on this new tool they added and a tool that they trained the model to be very good at called the memory tool. I think the memory tool is probably the most interesting aspect of this model release. And this is, a new flagship model release. So there's, of course, various scores that Sonnet 4.5 is presumably better than, even Opus, but clearly, Sonnet 4, it's a direct predecessor, better at various tasks. But I think the most interesting aspect of this release is actually not just these benchmark scores, but this training around the memory tool. So specifically, there is now this new memory tool. It's kind of like an official Anthropic tool that Sonnet 4.5 has been trained to use very well. And you can see that this memory tool is actually basically treating the agent's long-term memory as a file directory. And I think this kind of makes a lot of sense given the trend of how models have been trained to be better and better at coding over time. But functionally, what this means is that you can now kind of enable this tool with Sonnet 4.5, and basically the model will kind of try to use this memories directory as its long-term memory bank. This is kind of like an extension of the AGENTS.md idea or the Claude.md file. So yeah, if you're familiar with the coding agents, if you use Claude Code, Cursor, Codex, for a while now, maybe like 6-12 months, there's been this concept of like the markdown file that you're going to put in your directory. A popular one now is called like agents.md. I think this is supported by, kind of supported by the majority of coding agents apart from Claude Code. But yeah, you basically make this file in your repo, and then you kind of add things. These are kind of like memories, but more like instructions for an agent for how to use your code or how to use your repo. So yeah, in this case, you were kind of describing to the agent how to set up the entire repo. And then I think the more important thing that people often like to use these kind of like memory files or agent.md files for is to communicate code style, like things that a human engineer would know about the repo if they had been at the company for a long time, but an agent just isn't going to know. It's not immediately evident from the code. So you can kind of like write it down into these files. And coding agents like Claude Code or any of these other ones, Jules, AMP, Codex, they will kind of treat this file, the agents.md file, as memory. So going back to the memory tool is kind of like an extension of the Claude.md or the agents.md file. So it's still treating, memory as files and files as memory. But you now have a brand new directory, this like memories directory, and this is where you're going to store all the files. So this means that you can actually have many more than just one memory or one memory file. You can have, kind of an infinite amount, as many files as you can store in your computer. So yeah, I think this is it's very interesting because it's a very open question how to actually implement long-term memory for LM agents. The language models themselves don't have memory. And yeah, I think this is really, this idea of like memory as kind of like files is very, very interesting. And it seems to be the direction that kind of everything is trending towards. So I think the concept of kind of memory as files or memory as like editable sections of context, it's a very interesting idea. It's something that a lot of people have been working on for a very long time, ourselves at Letta included. So I do want to kind of cover maybe like a brief history of how we got here, how we got to like the memory tool in Claude, in the Claude API or like Claude Sonnet 4.5. But if you're interested in just seeing this tool in action and understanding like very specifically as an engineer, like what do I need to know about this tool, I'll leave a timestamp so you can just jump ahead to later in the video. But if you do want to kind of maybe see this like brief overview, this brief timeline of how we even ended up with like a memory file tool, I'll cover that right now pretty quickly because I think it's very interesting. So some of you might be familiar with the MemGPT paper. So this is a paper that myself and a few others who are actually at Letta now worked on during our grad school years. And the key idea behind MemGPT, so for context, like MemGPT came out when when GPT-4 had approximately come out, when context windows are around like 4K, 8K, so very short context windows, but tool calling existed. So tool calling had just come out. It was called function calling at the time, had just come out in the in the OpenAI chat completions API. So short context windows, but tool calling exists. That's when MemGPT came out. And the key idea behind MemGPT is, well, if you have very good tool calling, or you have tool calling, maybe at the time it wasn't very, very good, but it was still pretty good, even when it first came out with GPT-4. Well, why don't you just allow the LLM to kind of edit some section of its own context window, or potentially like this context window is persisted into, like, let's say a file, but just like let it edit the context window via tool calls. So you give the agent tools like memory insert, memory delete, memory rewrite. And what that's going to do when you execute that tool is it's actually going to edit, some section of the context window that is persisted to a file or a database. And another kind of interesting thing about this model is that you are kind of, because you're giving the LLM these tools to edit its own context window, you're making the LLM self-aware of its own both limitations and capabilities. So you're kind of making the LLM very aware that you need to be the one that is going to bring fresh context, relevant context into the context window. You are the one who needs to flush it out. Like old context, you should probably consolidate, delete it, or old memories. And then also one interesting thing we did in the initial MemGPT design, which is now kind of like baked into some of the agent architectures in Letta, is that actually when the agent gets very close to reaching the maximum context window length, we actually would kind of like send these reminder messages to the agent, telling the agent, hey, you're almost out of space. Consider, your context window is going to get summarized soon. You should consider making some, jotting down some important notes from the conversation if you haven't done that already. And I bring up that last point because Cognition, the company that makes this coding agent, Devin, they released their own blog post about Claude Sonnet 4.5, and they're kind of saying that, Claude Sonnet 4.5 is the first model that is aware of its context window. So they're saying that Sonnet 4.5 actually has like context anxiety. So the model kind of like is aware as the context window is getting larger and larger that it's going to either like forget or have context summarization or compaction happen. So in their case, they actually said, hey, we leave like the 1 million token context limit, but we actually don't like ever really let it get close to that. So that prevents the model from kind of seeing that it's close to 1 million and then getting kind of like, maybe spending too many tokens thinking about, I guess in their case, they're saying they saw the model taking shortcuts or leaving tasks incomplete when it believed it was near the end of its window. So doing kind of like weird things just because the model is like very, very meta. So how does that relate to MemGPT? And what I was just talking about, how like even in MemGPT, this paper, so the MemGPT paper came out all the way back, in the like near the end of 2023. And like I was saying, in the MemGPT paper, we kind of put you can even see in like these original figures, we have the idea of like a system alert. So what's the difference between like the system alert that goes into MemGPT or like whatever model? It doesn't have to be Claude. It could be like, I think at the time, GPT-4 predominantly, or like Llama 2. What's the difference between this and then what Cognition is talking about? Well, the big difference is that you don't need in Sonnet 4.5 to put this alert in. Like Sonnet 4.5 is kind of self-aware. It has been trained to kind of like have this relationship between seeing a lot of context in its context window and understanding implicitly that this is happening, that it's like getting close to the context window limitation. So it's a very kind of interesting development that like this sort of meta-ness of the agent or meta-ness of the model, the model to be very self-aware about its own context window, its limitations as a language model, is getting pushed into the model itself. So for better or worse. I guess like with Cognition, they're obviously saying that this caused some problems. But I think overall, this is generally a good thing because it makes the model like a lot better at using tools to manipulate its context window if the model also knows that its context window is finite. All right. So I think in like the history of the self-improving file editing memory agent, I think a lot of the genesis of this can be traced back to the ideas in like MemGPT. But what happened like after MemGPT? What were like the big trends? I think the big trend that happened after that is very relevant to kind of how we ended up with the memory tool format that Anthropic has today is the coding agents. So coding agents are incredibly popular. I think it's definitely one of the, if not the, biggest application of these language model agents. The coding agents have become very, very good at, through progressive training in this kind of domain of coding, they become very, very good at doing things like editing files. So you can see, I'm still in the Claude docs here, but this kind of applies across the board. Things like Claude, the underlying models like Sonnet, Opus, they become very good at using tools like Bash that will allow them to kind of like run commands instead of, let's see if I can find a good one here. So, like run commands like pip, cat, but then also they're very, very good at editing files, right? Because a coding agent, it needs to be able to kind of make line edits, do big bulk replace jobs. So a lot of that can be done through Bash commands, but in many cases, the models have been trained to use these like file editing tools to do like string replaces, line inserts, line deletions, things like that. So through kind of this pressure to make the models very good at coding, the models have become very, very, very good at using or manipulating text files, or basically like, files of code. So because these models are now so good at using file editing tools, it would make sense that if you want to make them good at memory editing, or like have long-term, give these LLM agents the ability to have like very long-term memory, why not kind of like piggyback off of all this progress and make the models very good at using files and kind of just treat memory as a file, right? I think with agents.md, we were starting with, treating memory as a single file. I think for a coding agent that's only doing one thing, I think that can be okay. Like the coding agent only knows one world, it only knows the repo it's living in. In that case, maybe it's fine for quote unquote memory to just be a single file. But I think for broader applications and then just in the long term, coding or memory definitely is much more complex than just a single file. So in that case, well, why not just make it a directory, right? So that's kind of exactly what that's exactly what the Anthropic team has done here with the memory tool. You basically have, you basically are treating memory as a files directory, and then you kind of allow Claude to create, read, update, and delete files in this directory. The one last thing I want to cover before I kind of jump into showing this off and playing around with it a bit is that the memory tool with Anthropic or with Claude, it's actually client side. So what does this mean? This means that like similar to when you're using Claude Code, the files are not like uploaded into Claude servers unless you're using a sandbox, or Anthropic servers unless you're using a sandbox. Like Claude, the model is operating on files that are stored locally. So it makes a lot of sense that like if memory is implemented in their case as files, you should do the same thing. Like the memory directory, this is also kind of like a local directory or they expect it to be a local directory sitting on your computer. Yeah, so it's not like these memories are files stored on their side. They're stored wherever, like, for example, your code is stored. Okay, so now I want to actually kind of like do a quick run through to kind of show you the potential of what a memory tool like this looks like, and what it looks like for a model to have been like trained to be very, very good at self-editing its own memory, like Sonnet 4.5 has been. Okay, so I wanted to go through a quick example showing off Claude 4.5's memory editing capabilities with this new tool. I'm going to do it in Letta, and I'll kind of explain why in a second. So if you're not familiar with Letta, Letta is an open source platform that allows you to build what we call stateful agents. So basically these agents that have long-term memory that is persisted to disk or persisted to, you can call it files. And the memory is editable over time. So in this example, I just, created one of the starter kit agents. The agent has a memory about itself. Or actually this is memory about the human. So yeah, the memories are divided into what we call blocks of memory. So in this case, it has, a block dedicated to the human, storing key details about the person you are conversing with. So kind of the first person of the agent. And then it has a memory block dedicated to itself, kind of like the storing details about your persona. So in this case, it's saying some stuff like, I am Sam, kind of some generic sci-fi persona. And the important thing to note about Letta is that these memory blocks, they're not fixed. So these are in many ways very, very similar to files. The only difference between memory blocks and files is that every single memory block, it it doesn't have to have it, but we generally recommend having a description. So some sort of way to describe to the agent or the human reviewing this, like, what is this memory block or file even for? But the way you edit these memory blocks is actually through tools. So again, this is very, very similar to kind of the approach that Anthropic's describing. If you want to edit these memory blocks, you use tools. Like in this case, the default ones we have are like insert or replace. These can do kind of like line edits on these memory blocks. So like in short, it actually turns out that if you want to see like how powerful Sonnet 4.5 is at using the memory, the memory tool, the special memory tool has been trained or post-trained on. If you really want to see the full potential of it, it's very, very easy to see inside of Letta, because Letta already has, all the scaffolding set up to have effectively these files or these memory blocks stored in disk that Claude Sonnet 4.5 can then access. So what we've done here is we actually have created a brand new memory tool that is just called memory. So we'll kind of remove these ones. These are the classic memory tools that we generally attach to your default agents, very much inspired by the original MemGPT work. So you could see that we had two tools. We had like a memory replace, and then we had a memory insert. And the new tool that we've added to work very well with Claude Sonnet 4.5 is just called memory. So if we hop back to the Claude docs, they actually have kind of like the full spec of like what this memory tool should look like. In their case, you can always just enable the memory tool as like kind of a built-in tool, and then the schema is given to the LM automatically. Or you can kind of create a tool that kind of mimics it very similarly, which is what we did. So you can see that the memory tool, it's kind of like an omni-tool, right? There's only one function called memory, but it can be broken down into different like subcommands, where you can do like memory, then you set a keyword or a command view, and this will kind of like view, it'll open the memory file, kind of like opening a file for Claude Code. You can also create memories. So in this case, the agent will call like the memory tool, then call command create, then it will make a path. So this path just means, hey, every memory goes in memories, but specifically I'm going to create a new memory called notes.txt. I'm going to put some, here, the meeting notes, discuss project timeline, kind of a scaffold for some notes. It has all the standard things we expect, like the string replace. In this case, it will start, calling the memory tool. So this memory omni tool, subcommand string replace, and then replacing old color with old favorite color with new favorite color, insert, delete, rename. Okay. So basically the way I would describe this memory tool is it's an omni tool. It's a single tool, but it has many subtools inside of it. So if we hop back to Letta and we look at the new memory tool that we added, it's the same thing. So you have, one high-level tool called memory, and then you have all these different and then you have all these different subcommands you can do. You can do the view command, create, string replace, insert, delete, and then you have a whole set of like optional keyword args, and these are the way that you're able to pass for each subcommand some subset of keyword args. All right, so that's enough talking. Let's actually just test this out. So we can choose one of these like starter messages that is just going to intentionally trigger a memory edit. So yeah, verify the integrity of your memory systems by editing them. All right, so what happened here? Okay, so we can see that, Sonnet 4.5 here, it decided to edit the human block, or in its case, it decided to edit what it is considering, path humans or path memories human. So it is really treating this as a file. So this is like very, very closely aligned to the expected behavior of if you were using files. But in Letta, we're not using files per se. We're using these like blocks of strings that are stored in a database, which you could consider files, but they have like very other cool properties because they're implemented as memory blocks, where you can like share memory blocks among many different agents very easily, have them all like cross-editing them. But yeah, you can see that it used the memory tool, used the string replace, and I replaced this old string, so I guess like the starter text, and I replaced it with something brand new. And yeah, when it calls this tool, it also gets an output confirming that the memory block was successfully edited. in this case, let's see if we can create, or we can kind of trigger the model to create a to-do list, and to create a to-do list in memory as opposed to just like doing it in the message history. Now I'm going to send a message that says, I want you to test your memory systems, create a mock to-do list, and walk through it step by step until you finish it. So what we should see here is the agent it currently has, these default human and human and persona memory blocks. It should create a brand new memory block called to-do list and then kind of like edit that progressively as it goes through. So let's see what happens. Okay, so the agent, I didn't have to say that you should create a new memory block. It just inferred that it's going to create a new memory block for the to-do list. All right, so it's kind of off the races here. It decided, it's going to run this memory test on September 30th. It's going to do a search previous conversations. Then it's going to update the human block. Oh, you can see it checked it off. It didn't quite do it in Markdown style with the X. It kind of put like a check Unicode in there, but I think it's okay for now. So yeah, search, what's it doing right now? So yeah, it's making a bunch of memory updates, search the conversation, then it updated the human blocks. So yeah, it updated that I'm interested in AI capabilities. I like systematic step-by-step demonstrations. Then I marked task 2 as complete. Now it's on task 3, add a reflection. What reflection did it add? September 30th, completed a memory system test exercise. We'll do after that. Okay, this is really going pretty fast. Having a hard time keeping up. So yeah, then it marked all tasks as complete. Well, okay, in the meantime, while we were reading all this, it kind of like went through all these tasks. Task 3 was add a reflection. Task 4, mark everything as complete, and write a final summary. Status complete. Wow, okay. Yeah. All tasks complete. I created the new to-do list block, search conversation history, yada, yada. Okay. And yeah, I mean, we can actually then tell the agent like, great, why don't you clean things up and remove the to-do list. So the agent can not only create blocks and edit blocks, but it can also remove them. So you can see here, the to-do list block just disappeared. I removed the to-do list memory block. There we go. So, and the way this works is it called a command called memory, this memory omni-tool. And inside of the tool itself, it set the subcommand to be delete, and then it set the path to the quote unquote file. And in our case, this is backed by a memory block in Letta. So another very natural way to use these sorts of dynamic memory blocks is to actually kind of allow the agent to get better and better over time at using its tools. So if we created a fresh agent here, so let's again kind of like set this up. Let's kind of drop the old memory tools. Let's put in the new one. So we could tell the agent something like, just gave you a brand new memory tool. I want you to learn how to use it through testing it and store your findings in a new memory called tool. Yeah, it would be like tool learnings or something like that. Okay, so this agent is going to start by probably creating the new memory block. Let's see. Okay, great. So it created this new memory block called tool learnings. I guess I could have let the agent decide what to call this. It put in a description. This is for documentation of memory tool capabilities and learnings from testing. Kind of put a date on it. Yeah, so kind of like put some things in here of like what to test. All right, so you can see that it basically created this new memory block, and then it's running through a bunch of tests to test how the tool works. And yeah, what are its key insights? Each memory block has a 2,000 line character limit. Line numbers are displayed. All operations return confirmation messages. I can create structural documentation. So yeah, you can imagine that if you had like a very complex tool, like for example, like a web search tool, and like if we look at this web search tool, it has like a ton of different parameters. It can use like filter by different categories. You can decide to include text, include domains, all these different things. So it's actually a pretty complex tool to use that actually can kind of be like mastered or kind of learned over time. So you can have your agent actually just dynamically create a memory block dedicated to learning. It could be generally about how to use tools. It could also be specifically how to use the web search tool. And then one very cool thing in Letta is these tools or these memory blocks can be shared across agents, right? So you can kind of create another agent, and you can take these blocks that are from other agents, like a memory tool, you can actually take blocks from other agents, like the block about how to best use the web search tool, and you could attach it to another agent, right? So you can kind of like transfer this knowledge over time, very, very easily in Letta, just because, even though the agent, the way the tool is used, it kind of appears to be writing to files, whereas really writing to is kind of this database of memory blocks, which is in many ways much more powerful than just writing to simple files. All right, so the last thing I want to show off is just again on the ability to like dynamically create memory blocks, and how that might come into play in some other applications. So another very obvious one to think about is kind of a use case where maybe you started with like some memory blocks that are kind of like default, like the human and persona one. But let's say there's maybe like 2 different humans chatting with the agent, or maybe there's 3 or 10. It might make sense for the agent kind of like no longer just use like a single human memory block, but instead kind of like shard out that single human memory block into many different memory blocks. So let's see if we can actually like do that with this new memory tool. So yeah, we can start it off with a very simple message like, "Hi, nice to meet you. My name is James." All right, so the agent's going to update its memory block, likely about the human. Yeah, okay, so it kind of puts human, name James. All right, so let's try to get the agent to decide to turn this memory block, that's the human memory block, into like multiple memory blocks. So I say something like, "Hi, I'm David. I'm James's roommate. I also have access to this chat. We both share the computer in our dorm." All right, so let's see what the agent decides to do with this information. I think there's like 2 things that can happen. It could decide to just update the human block. Okay, so it decided to just update the human block. Let's try to like coax this model a little bit further by doing something like, okay, actually the model is asking, or the agent is asking, "Do you often use 2 shared accounts like this, or is this something new?" Yes, this is a multi-user chat interface. Many people will be using it. Right now, it's actually Amelie chatting, but it was just David before. Right now, nice to meet you. Don't you refactor your memory to store memories for each person? Okay, so in this case, I'm going to do a little bit like coaxing. This is the kind of stuff you could definitely put into the system prompt itself. The system prompt in this case is really, really simple. It just says like, "You're a helpful assistant." So this sort of like behavior where if, there are many different people, you should store different memories for each person, that's definitely very doable via system prompt or system prompting. All right, so it decided to finally make a new memory block called user Brian. Clean up your memory. Why do you have both human and Brian? Or let's say like, why do you still have the human block? It's kind of doing some direct memory guidance here. Yeah, so the agent's saying, Brian is right. I created a separate memory block for him, but I still have the old human memory block designed for a single user. Actually looking at the human memory block, the human block, it already has updated multi-user information. So maybe I should delete it. Maybe I should repurpose it. So what did it decide to do? Okay, so it's actually asking me now what. Okay, so it's actually asking me now what to do. Yeah, should I delete it or turn into a lightweight directory? Just make a block for everyone you meet. Yeah, Brian is Brian is right. I should create individual memory blocks for each person. Okay, so let's see what happens now. I'm guessing it's going to create one for, all right, one for James. Let's collapse this. It's creating one for James, one for David, one for Brian. There should be one more. There we go. Yeah, one for Amelie. Yeah, and let's see if it deletes. Okay, what did it leave in the human block? It left. Okay, so this is kind of like a high level block. So okay, having a pretty meta conversation here about the agent's memory, but let's see. Yeah, Brian is right. If I'm creating individual blocks for each user, the human block is redundant and cluttered. I should clean it up. All right. Okay, interesting. So it decided actually not to delete the human memory block, but instead it decided to kind of like make a note that they should be creating individual memory blocks for each person I meet. So yeah, we could also just say like, hey, why not just delete it? Let's see what happens. Okay, well, it's kind of actually disagreeing a little bit. Okay, so I ended up deciding to delete it. You can see, boom, delete it. So yeah, I mean, basically this memory tool that we've been looking at, it's extremely dynamic, extremely extensible. Basically, it's like an omni-tool. Like I said, it's a tool that can do everything. It has all the different memory operations you could possibly want. Yeah, creating new blocks, deleting blocks, editing them, line edits, whole string replacements. You can also, the agent also has the ability to update the descriptions very easily. So yeah, hopefully you enjoyed watching. If you skip to the end, I think basically Sonnet 4.5 extremely good at this concept of kind of editing memory through tools. This is something that we've been working on all the way since like MemGPT. I think now the models themselves are getting extremely good at using these tools. And yeah, I think Letta is like a really, really cool playground to play around with this concept. If you use the memory tool directly from Anthropic, you have to kind of manage all this file scaffolding yourself. But in Letta, Letta comes with all these memory blocks kind of baked into the system. They can be attached to a single agent, detached from agents, kind of like free floating, shared memory blocks, so like one memory block for 100 agents, one memory block just for one agent. The possibilities are pretty limitless. And with models like Sonnet 4.5, the models now are incredibly good at understanding kind of how to do these memory operations. So yeah, definitely would recommend giving Sonnet 4.5 a try. Definitely try it out inside of Letta with the new memory omni tool. And yeah, let us know what you think. Really excited to see what you guys build.